Tool use, sometimes called function calling, lets Claude request that your code run a specific function, looking up an order, querying a database, calling another API, and use the result to continue answering. This is the mechanism behind almost every agentic behavior discussed in the rest of this book. It's not a single API call. It's a loop. You send a request with a tool's parameter describing available tools. Claude's response may come back with stop_reason tool_use and one or more tool_use blocks specifying which tool and what input. Your code executes the actual tool. Since Claude never directly runs your function, you send a new request with the result as a tool_result block, and Claude uses that result to produce a final answer or requests another tool call, repeating the loop. The input_schema is a JSON schema object, and its quality directly determines how reliably Claude calls the tool correctly. Write descriptions like documentation for a new teammate, not a one-word label. Look up an order by ID and return its status, items, and shipping date is far more useful than gets order. Mark required fields explicitly and give enum constraints where the valid values are a fixed set rather than free text. And give each tool one clear job. A tool that does 5 unrelated things behind one name is harder for Claude to use correctly than 5 well-named tools. You can control whether and how Claude uses tools. Auto, the default, lets Claude decide whether a tool call is needed. Any means Claude must call some tool, but can choose which. A specific tool name forces that particular call, useful when you already know the next step and just want Claude to format the input correctly. And none disables tool use for the request even if tools are defined. Forcing a specific tool is a common technique for structured output via tool use. You define one tool purely as an output schema and force its use. Claude can request multiple tool calls in a single turn when the tasks are independent, looking up 2 different order IDs mentioned in one message, for example. Your code should check for multiple tool_use blocks in one response, not just the first. Execute independent calls concurrently where your infrastructure allows, and match each result to its call via tool_ID, since order isn't guaranteed to be preserved by every client-side handling pattern. Real tools fail, an order ID doesn't exist, a downstream API times out, a database query throws. Don't let this break the loop. Return the error as a tool result with is_error set to true, and let Claude decide how to respond. Retry with different input, apologize to the user, or ask a clarifying question. This is more robust than catching the exception in your code and fabricating a text response yourself. Claude often handles the failure gracefully if it's given the real error rather than a silent fallback. Tool definitions and tool inputs cross a trust boundary. If a tool input can trigger a real side effect, sending an email, deleting a record, making a payment, treat Claude's tool call the way you treat any user-triggered action. Validate input server-side. Apply the same authorization checks you'd apply to a direct API call. And don't assume a well-written prompt is a substitute for real access control. Never trust a tool call's input more than you trust arbitrary user input, because indirectly, that's what it is. Extend the running triage assistant with a lookup_customer_history tool that returns a mock customer's past ticket count and tier. Run a ticket through the full loop and confirm the final response references the tool result correctly. To recap, tool use is a loop. Claude requests a call via tool_use. Your code executes it, you return a tool_result, and Claude continues. Claude never executes code itself. Tool schema quality, clear descriptions, required fields, enums, single responsibility, directly drives call accuracy. Tool underscore choice controls whether and which tool is used. Handle parallel tool calls by matching results to calls via tool underscore ID, not position, and return real errors as is underscore error tool results rather than fabricating fallback text. And treat tool call inputs as untrusted, the same as direct user input, especially for tools with real side effects.